Good evening,
Good
everyone.
evening, sir. Good evening, sir.
Good evening,
Hello,
sir.
everyone. How can you all read me?
Radio 5, sir. Victor Tango, Victor Victor Alpha.
Radio 5, Victor Tango, Michael.
Clearly, students, make good replies.
Radio 5, Victor Tango, Sierra Uniform Bravo.
Radio 5 Victor Tango Alpha Mike Alpha.
Radio 5, Victor Tango, Mike Alpha November.
Radio 5 Victor Tango Victor Delta.
Radio 5 Victor Tango Sierra Sierra Hotel.
Radio 5 Victor Tango Sierra Hotel Romeo.
Radio 5
Radio,
November Alpha November.
Radio 5 Victor Tango Victor Alpha Romeo.
Radio 5 Victor Tango Tango Papa Kilo.
Radio 5 Victor Tango Victor India Romeo.
Okay, very good evening, everyone. I can see Varat, Nandini, Subhajit, and Vivek Dakad. Welcome to the class, students. Nice to see you all. And then we have Sankalp, Ayan, Nukul, Mohammad Azam, Vivek Yadav, Sujal, Twarita.
Good evening, sir.
Very good evening, Nukul. Pankti, Nehal, Shraddha, Sparsh, Manan, and Viren. Very nice to have everyone. Nukul, nice to see you. I hope everybody is doing well. Yes. Students, take a quick look at what we had done in the last class. Okay, quick look, D long, D lat. See if you have any confusions. Because today we have a short session, we are going to discuss all important points that we have to, work towards. And tomorrow's session will be an amalgamation of our 3 sessions on the Earth. Third session is today. Tomorrow would be our final wrap-up session on Earth, including the topics done on day 1, day 2, day 3. So tomorrow we are going to have a lengthy session. We'll start at 5 and we'll want to stretch around till 7:30. So I'm just giving you all that advice that make sure you're available. Not every day we'll have 1.5 hour lectures. We know generally we have 2.5 hours to 3 lectures for navigation. So that's what we are going to do. So that is a soft update to everyone attending the session. Tomorrow, 5 o'clock, we'll meet again and we'll be there till 7:30 or 8 o'clock. We'll give you a good break in between the class. Okay. So what are the points that I'm going to discuss with you all today? Now, you must have seen me use words like great circle, Rhumbline, right? Today, we are going to learn in detail about these two. We are going to see what is convergency, what is the formula, okay? And these important things we are going to clarify. We're going to do a couple of points on these, what do we say? These concepts, basically. So what is Earth? Earth is a planet. Its shape is oblate, spheroid, or geoid. It's not a perfect sphere. But for all our navigation calculations, we have to imagine Earth to be a perfect sphere. So whenever we are making any calculations, we'll draw the Earth as a perfect sphere. What all things have you learned to do so far? So far, you have learned to do how to find distance between latitudes or distance between longitudes. And we also know that if there is something called a great circle or meridians, then 1 degree is equal to 60 nautical miles in length. Now, what are these angular measurements? Why are we doing these angular measurements? It's all to help you find the directions and the route to fly to your destination. Okay. Why are we doing this? Why do we need to learn about the Earth, about D lat and D longs? It is so that we can determine the positions on the Earth, and then we can determine the best possible path we have to take from our departure point to our destination point. Okay, so far we have learned how to measure the distance to be traveled between your departure destination, departure latitude, longitude, and arrival latitude, longitude. I want you all to just take a quick look at it, and if you're thorough with D lat and D long, if you're thorough with it, great. If you have any doubts, quickly ask. Okay. I hope everybody is listening, and I hope you're following the instruction that I've given you right now.
Affirm Victor Tango Alpha Mike.
And students, is there any background noise from my side? Let me know.
Negative, sir.
Okay, thanks. So these are the 4 points that we need to keep primary focus upon based upon our numericals. And somewhere your D lat, D long are the basics behind all these terms that we are going to do. Okay. Now, what do we know so far? A, 34 degrees north, 101 degrees east. And B, that is your destination, would be 35 degrees south, 101, 104 degrees east. This is your example. I want everybody to quickly solve. Okay. Find D lat and D long. Remember, you cannot find both together. You need to first find one and the other. What is the strategy for D lat? The strategy for D lat is to look at the Earth from the front view. You get your equator, that is 0 degrees north-south. And then you start plotting your latitude. Point number A, 43 north, I would make somewhere here and write 34 north, I mean. Okay, got A. And B would be 35 south. I would make somewhere here and put 35 degrees south. These are my latitudes. My latitudes will always be on one meridian. Okay. Which is that meridian right now? That meridian is this meridian that I am showing you all this. From the front view, we are measuring your D lat between these 2 points on a meridian. What's the value of this meridian? 090 degrees east. Okay, so you find your D lat this way. It is very easy. The first point you need to remember is to imagine the Earth from front view. Okay, Earth front view. Okay, remember that is first technique where you will always be confused if you have not practiced enough. D lat you will use measuring or using this technique. Okay, this is for D lat. And for D long, and everybody is going to give me the answers in the chat box. For D long, what will you do? You'll imagine the Earth from top view. The center is North Pole. And you will write down Earth top view. Like this. And you will make prime meridian. For latitudes, your equator is the reference. For your D long, your prime meridian over here, PM 000 degrees east-west. And you can make anti-prime meridian 180 degrees east-west like this. Okay. And your D long over here, we have to measure. Your A D long is 101 east. Where is 101 east? This is 90 degrees east, 090 degrees east. So I make that also. My 101 east is somewhere here, 101 degrees east alpha. And what is Bravo? 104 east. Bravo is 104 east, somewhere here. Bravo 104 east. So my D long is this from A to B. And I also have my direction. Now, how do I verify my direction? From top view, Earth rotates in anti-clockwise direction like this. and this is east. Remember that Earth's direction of rotation is east from top view. And with respect to your these directions, if you're going up, it's north. If you're going down, it's south. So you're going this direction, that is southbound. So you get two directions, all right? One, to travel from latitude to latitude. When you're traveling from latitude to latitude, you need to maintain one common longitude. And then when you're traveling from longitude to longitude, you can maintain that particular latitude. You have to keep one thing common when you're solving this. What we are solving right now is also sometimes known as departure or part of departure, because we have constant directions. Because whenever you're flying to find d long, either you will have east or west. And whenever you're finding d lat, either you will have north or south. Okay, but we'll discuss when we discuss departure. This much should be thorough, students. If you have any confusions, feel free to ask right now. You have to just measure angular differences. From what I see, 34 to equator will give me 34 degrees, and equator to 35 degrees south will give me 35, so 34 plus 35. I don't do directly a mathematical equation, I solve properly. So 0 to 34 is 34 and 0 to 35 is 35 degrees. So I get around how much? 69 degrees south will be my d lat, and my d long would be 003 degrees east. 101 to 104, 3 degrees. Now for d long, students, because this is the top view, what you're looking at, this whole circumference right now, this circumference in yellow, okay? This is your equator. You need to know what you're looking at. And your equator is a great circle, and on every great circle, 1 degree will give you 60 nautical miles. So if you're traveling d long from Alpha to Bravo, 101 to 104, that is 3 degrees. 1 degree is 60 nautical miles. So 3 degrees would be 3, 6 are 18, 180 nautical miles. So here your d long is 3 degrees east, and your distance is 3 into 60 nautical mile is equal to 180 nautical miles. It is very easy to find out. The distance for d lat is not easy to find out because depending upon your latitude. Okay. So right now, this is only true if d long is tracked on a GC, great circle, in bracket, that is equator. Remember that. Only true when you are tracking with respect to this diagram or on the equator. The moment you are tracking d long not on the equator, then your distances would reduce because maximum distances are available on equator only. And I'm going to show that to you today. And that is where the concept of convergency comes into picture. And when it comes to d lat, over here also, if you're traveling from A to B, 69 degrees south, you will notice that you are on a meridian 0980. A meridian along with its anti-meridian together makes a great circle. So over here also, you are on a great circle. So your d lat is 69 degrees south, and your distance over here is 69 into 60. Okay, 69 degrees, and 1 degree is 60 nautical miles, because this is also a part of a great circle. Meridians and anti-meridians together make great circles. So use your calci, students. If you have a, what do we say, a scientific calci, use that, or you can use any online calci that you have. Generally, this kind of calcis are allowed along with your CX3s in the exams. We will need this for these purposes only. If you have ever wondered why you need scientific calci, so these are the sums why we need scientific calci major of the times. Okay, so I will simply do, right now we don't see any scientific formula, but we are going to see. I'll simply do 69 into 60, and I get 4,140 nautical miles. This is a basic understanding, students. Okay, only when you're on a great circle. 69 degrees is equal to, how much was it, students?
4140.
4140 nautical miles. Now, ideally, if I want to travel from A to B, and if I take this path, then I'm going to exhaust a lot of fuel because I'm going to travel what? 4140 nautical miles plus 180 nautical miles, almost 4,500 nautical miles I have to fly to reach from this point to this point on the earth. And this is not the shortest way. This way is good because it gives me constant directions. First, you either fly south and then fly east, or first you fly east and then you fly south. With respect to two constant directions, my job becomes very easy. But then commercial aviation is all about saving fuel. That's how you earn profit. So this is not a good way for us, and we need a better way to travel. And the better way to travel is to find out whenever you have any 2 points, like for example, A and B, you make a great circle that passes through both the 2 points. Now, something about a great circle, if I give you any 2 points on the surface of the earth, no matter where they are, they could be next to each other, they could be very far away from each other, one great circle can always pass through 2 points. Remember that. So if I'm taking any 2 points like A and B with respect to the DLAT diagram, then if I make a great circle in green, then this becomes the great circle passing through those 2 points. Okay. So the first job to find the shortest distance is make a great circle passing through your 2 points, which will be a departure point and a destination point. Once you get that great circle, use the shorter arc of the great circle. Now this great circle has 2 arcs between A and B. This arc directly going southbound, A to B, and the second arc is, I'm going to make it in pink. And the second arc is from A to B in this direction. 2 arcs. Now, which is the shortest arc? The shorter arc is the DLAT that you have made already, which is the red arc. So by rule, if you make a great circle between any 2 points, and when you take the shorter arc between the 2 points, that shorter arc is actually the shortest distance between those 2 points. Okay. So write this point down. To find the shortest distance between departure point and destination point, make a GC, that is great circle, between those 2 points. In bracket, you will write note, at least one great circle will pass through any 2 points on Earth. Right, second note, if 2 points are antipodal, if those 2 points are 180-degree opposite to each other, that is the meaning of antipodal. That is 180-degree opposite to each other, then infinite number of great circles will pass through those points. Okay, students. Example is North Pole and South Pole. North Pole and South Pole in the geometric circle shape are antipodal to each other. So n number of great circles can actually pass through those 2 points. But other than those 2 points, if there are any 2 points that are not antipodal, then at least one great circle will always pass. Okay. So to find shortest distance between departure point and destination point, make a great circle between those 2 points. Now, take the shorter arc of the great circle between 2 points. Students, remember the direction, okay? And remember the direction. This shorter arc between the 2 points is the shortest distance available between those 2 points. Okay, students, read this at least twice. See if you understand what it means. I'm checking your answers now. We have 17 students and I've only received 13 answers in the chat box. Okay, students, you should understand that this is your 3rd session for the topic, and you know, we slowly increase the pace. We need feedback. I need to see your interaction. So right or wrong, keep sharing your answers, okay? Make it easy for me to track down. Vivek, you have just given me one answer in the beginning, but that is correct. D lat, D long, viral, correct. Okay.
Sir, actually, I missed the points you said.
No, not for you.
Due to network issue.
No, not for you. Not for you. Stand by. Whatever you have missed, students, please ask again. But the message was not for you, Mr. Yadav. It was for Vivek Dhakad. I'll be more careful with the names. Sorry. And whatever you have missed, please let me know. Viral, 3 digits. Your longitude has to be 3 digits. D long also in 3 digits. Vivek Dhakad, correct answer. Got it. Sankalp, correct answer. Subhajit, good. Subhajit, directions D long. Are you confused? Anti-clockwise is east.
I corrected that afterwards.
I will check. But initially, whenever you're submitting your answer, be double sure. Okay. Right. Good that you've corrected. I will come to it. Varad, D lat is good. D long, always give both answers in the same message. Varad, good job. D lat is correct. Manan, D long and D lat direction not mentioned in your first answer. Sujal, good. Sujal, directions not mentioned in your D lat, D long. See, without your directions, the answer is incomplete, students. Nukul, very confusion in understanding your question. Okay, not confused. I understand, but longitudes, you need 3 digits and keep some space, but answer is correct. Make sure you write it correctly. Subhajit, correct. Vivek, Yadav, good job. Answer is correct. Whatever you missed, but the answer is correct. Well done. Pankti, answer is correct. Shata, answer is correct. Girls, well done. Varad, okay, good. D long is correct. Sparsh, good. Need to understand topic again. Okay. See, it's very simple. Everything that I've shown here, you have to follow it step by step. Mohammed, have you missed the past 2 sessions on Earth? Have you attended, not attended? Let me know.
I attended
Azam?
last one section, sir.
Sorry?
Last section I have attended. Before that, I was not there.
Yeah, so it is very easy. It's not difficult, but we need to follow the basics. So
Yes, sir. I'll
I
go
think
through it.
somewhere, yeah. But write it down in the write it out in the parking lot. Okay.
Sure.
Viral, correct answer. Twarita, no problem. And whenever you will watch these 2 sessions, you'll understand. But it is as what I have seen. I've showed everything again. D-lat is the distance between two latitudes. And what are latitudes? Latitudes are angular measurements made from the center of the Earth with respect to the equator. So how many latitudes do we have? Azam, you also, everybody. This one more time, I'm repeating it for everyone. How much of latitudes do we have? If I have to make your latitudes, your Earth would look like this. Front view. This is your equator, which is a 0° north-south latitude. And latitudes are angular measurement made from the center of the Earth and equator. So if I'm making any angle with respect to the equator, like this, so this is 25°. The angle is 25 degrees, but the point of this line on the Earth becomes latitude 25° north. So we can get up to 90 degrees north over here, which is a point. Similarly, in the south, we will get 90 degrees south over here. And in the south also, if I'm making an angular measurement with respect to the equator and the center of the Earth, if this is the angle, then I say this is 33 degrees. And this point on the surface of the Earth becomes 33 degrees south. So our latitudes can either go up from the equator or down from the equator. 0 to 89 degrees is generally how we measure latitudes. 90 degree, we don't say latitude because it's a point. And when I make a line parallel to the equator, a line like this on 25° north, then all points on the Earth on this line will have a common latitude of 25 degrees north, like this. Similarly, this over here, a line parallel to the equator, all points on this line would be 33 degrees south. I hope everybody is thorough with it. And when it comes to meridians, see students, these are the basics. I'm repeating it so that it can be thoroughly embossed in your mind, okay? Top view, Earth, North Pole. Meridians are semicircles joining the North Pole and the South Pole passing through the equator. From top view, you can only see the upper part of the Earth or upper hemisphere, that is the northern hemisphere. A meridian cutting on the equator, 00 degrees east-west. This is known as prime meridian. And the opposite to it is 180° east-west, known as anti-prime meridian. For your latitude, your reference is equator. For your meridians and longitudes, the reference is this prime meridian. Anything east, if this is a 90 degrees with respect to prime meridian, this point on the equator will become 09 or 0 degrees east. Similarly, this point, it is 90 degrees from the prime meridian. This point becomes 09 or 0 degrees west. Total meridians you will have up to 180 east, and total meridians you will have 180 west. 180 east-west is one common line shared by both. Now these are meridians passing from North Pole to South Pole. Meridians and anti-meridians together make a great circle. Equator is a great circle. All other parallels of latitude are small circles. Okay, students? Any doubts, anyone? Good. Azam, you have any doubt?
No, sir. No, I got it.
Good, good. Nehal, are you following? Tango November Bravo Alpha. Students, the whole system, okay, the whole system of latitude and longitude, it's actually known as graticule. It's a system of imaginary lines, okay? Latitudes and longitudes are imaginary lines. We cannot see them, but our GPS, our satellites, all our coordinates, everything is real. The place where I am right now, if I turn on my GPS, I'll be able to figure out my latitude and longitude. And this latitude and longitude goes on with the system known as degrees, minutes, and seconds. Okay. It's like 1 degree, 20 minutes, and 22 seconds. This degrees, minutes, seconds is also this is how coordinates are pointed to give you more accuracy. Accuracy as in how narrowly can my latitudes and longitudes pinpoint to a particular position. So that in the end, when I'm determining my destination, I have to make sure the accuracy for my destination is such that I'm able to spot the runway following the coordinates. So the runway width is not too much. So I need that much of accuracy, maybe within a few meters. I need an accuracy within a few meters, if not more. Even 1 nautical mile accuracy is not good because you can find yourself anywhere between 1.8 kilometers. That is 1 nautical mile, 1.85 kilometers. So I need smaller accuracy. The more accuracy you will get when you write your answers into dividing the degrees into minutes and minutes into seconds. So 1 degree is equal to 60 minutes. Okay. And these are all in distances. And again, 1 minute is equal to 60 seconds, like this. And on a great circle, 1 minute is equal to 1 nautical mile. Remember that. Therefore, 1 degree is equal to 60 minutes is equal to 60 nautical miles on a great circle. Now, these lines are our guidelines, okay? I'm going to show you all something. I hope you have made a note of it, students. Quickly make a note of it. Okay. So the importance of great circle, students, is so much that, what do we say? Your daily flights, everything that is up in the air right now, they all are following present time, okay? Your flight dispatches, your ATS routes, ICAO, everything is designed with respect to what we are learning right now. All the ATS routes are actually shorter arc of a great circle between points. Definitely when you're doing a zigzag flight, like changing routes, that is a way to make sure you get navigational aid and traffic assistance. So sometimes you don't really have to follow the direct great circle track. Chances are you will be doing it majority of the flight. But in general, what I'm trying to say is the great circle track is followed every time when you are in air. And I'm going to show you that right now. Just stand by, everyone. So now this is one of the most leading flight tracking applications that we can rely upon, okay, in order to, spot something. Now you need to know that this app that we are using to verify, called Flight Radar, they sense the transponder data from all aircrafts as they are transmitting data in real time. And then they give us the real-time copy of that data on this application. If you're wondering how do they get this information, I think they have legally acquired the rights to do it. So a transponder is that system where you get all these details. Not there might be chances a few details are not there in the transponder. What is there right now in the flight radar tracking capacities. So this plane is flying in real time. Go airline, some plane. So if I'm just clicking on the plane, it is showing me a route. You see the straight route, and it had little slight turns over here from Mumbai. Once you have departed nicely, this is your ATC clearance before you take a right, then your initial climb. Then somewhere this point where the color is changing, you have to start it to resume a normal navigation. This curve that you see right now. And following the straight line, okay, the pilot is just flying straight, 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 straight. And this is the route. Somewhere you see the direction is going to slightly vary based upon how it is tracked between the navigational aids. But majorly, my direction is going in one, and then it is going to take a right, and then further, where's the destination? Chandigarh is the destination. Bombay to Chandigarh. These are ITA codes, okay, not ICAO codes. See, this is Chandigarh. Okay. Now this, if you're wondering what this line is, this line is actually a short arc of a great circle. Students, ignore the ads, okay? I'll be upgrading it within a week's time. So look at this point now. The plane departed 25 minutes ago, and the plane has traveled 286 nautical miles, kilometers, and it has to further cross 1060 kilometers. Okay. For us, these need to be converted into nautical miles. You can change that in the app also, but I'm just showing you all how do we get this distance. We get this by finding out the length of the arc on the great circle that I'm going to follow, the shorter arc. What I'm going to show you, the registration is there, country of registration is there, type of aircraft is there, and then your altitude is 37,000 feet that the plane is flying upon. The actual altitude is 36,975, but they are trying to maintain a flight level of 370. This track is what I'm trying to show you. TRACK. Can everybody see it? TRACK 19 degrees. This is your great circle track. And right now, in order to stay on the shorter arc of a great circle to find the shortest distance for you for this aircraft, okay, this aircraft, it has to maintain a direction of 019 degrees. When I say track, it is the value of your direction. Okay. And this 019 degrees is the great circle track. Now the pilot is going to fly straight. The pilot earlier had a different track. Now the pilot has slightly changed the track over here. So earlier the pilot was close to 001 or 002 or 003. Over here the pilot has changed from that to 019er, and that 019er is your directional value. That's why I started your navigation with directions. So you need to know what are your directions. Straight north, east clockwise from north 90 degrees is east, 180 degrees south, 270 degrees west, and then further 360 degrees north. This is what we have to learn. How to find out your great circle track by a certain given parameters. Because we need that great circle track for our flight planning purposes, because that is the shortest track that you're going to use. Okay. Now, there are certain rules by which these great circle tracks, rules that they abide. Okay. And those rules are very common and something that you see right now. Now, the plane is, if I have to look at the plane with respect to the west and east. So imagine you're looking at the Earth from front view. The whole map right now is designed with respect to you looking at the Earth from front view. Okay, Earth, India is somewhere on the equator. So the diagram that you make for DLAT is something you can imagine these diagrams to be. So if you have to divide east and west, anything going on your right is easterly, anything on your left going left is westerly. Now look at your aircraft. What is happening? The aircraft is flying towards the east. And its major direction is north, but from its position, it is going to its east side, north and east. Those are the two combined directions that the aircraft is flying at. Now, if I look at another aircraft, this aircraft, then this aircraft is majorly headed in the direction west, slightly towards the northern side with respect to where it is. So it has to fly west also, it has to fly north also, both for this aircraft, this Indigo aircraft. If I talk about this aircraft for Go Airways, now this plane is coming from north to south. So this plane is traveling from north to south, going southbound. And for this aircraft, the directions have reversed completely. And for them, if I reverse the direction, then they have been coming on the right side and then they're flying straight. That was actually west for them because it is going in that direction. So they are traveling a little bit westerly from their position that was Delhi. Now, all this, what is happening in real life is something that you are taught in your general navigation when you learn Earth. And that is great circle distances and great circle directions. Okay. What is really happening is something that you have to learn in a simple 2D diagram, which is this. And this is one of the most important rules of thumb that you will come across. Great circle directions. Okay. Sankar, in real life, your dispatchers will give you the route choice, and the routes are made by ICAO and air traffic services and all. The flight dispatchers will only choose the best route from available routes. Yes, but you as a pilot need to know all this because you will not directly work for a jetliner. Initially, you'll work as a student pilot and then maybe a private pilot for some time to build hours. And you need to know how to make all these calculations because when you're just flying one plane, you're the sole operator, then you have to be able to design your flight paths and do the flight dispatcher's job yourself also. In real life, you don't need to do all that, but that doesn't take away the necessity for you to understand these points and be able to come up to calculations and answers. This is one of the most important topics for your CPL syllabus. And this will be there for your SPL also, PPL also. But the level of calculations will be less in PPL and SPL. So although you won't do it, but you need to know the direction and track because it is really helpful. I'll tell you how. Great circle directions. Okay. Now I want you all to imagine the Earth. And I'm going to show you something, okay? Now let's say this is A and this is B. Okay, you cannot see the screen. Students, please let me know, okay, whenever you cannot see the screen. Sharing it again. Are we all following? Just let me know because I'm just... Yes, students,
sir.
please let me know.
Affirm, sir.
Affirm, sir.
So I'm going to show you Earth. And one important property. Okay, I'm making an oblate spheroid. I'm making an equator. If this is the equator, this is the North Pole, this is the South Pole. Okay, now I'm going to tell you this is the Northern Hemisphere. This is the Southern Hemisphere. Okay, divided by the equator. Now, if I have to travel from A to B, okay, I have realized earlier when I was doing D-long and D-lat that there is a way to fly with constant directions between any 2 points. If I say that this is point A and point B, then I have one route that I would fly like this in a constant direction. This route, if I follow, is called as a Rhumbline. Okay. RHUMB, Rhumbline. A Rhumbline, as I'll give you the definitions, you will realize it's any line joining 2 points, the line that will help you follow a constant direction. Now you have to understand, if I'm making all this, then from the North Pole to the South Pole, I have meridians also. There will be a prime meridian, and then there will be meridians going like this, all equidistant I'm showing you. Like this, like this, like this. Okay, now this is how your graticule looks like. You have equator as a latitude, you have certain meridians. You know that this is 090 east, and this is, the last one is 090 west from the front view. Your latitudes you can make anywhere we want. So if I have to go from A to B, then firstly, I would need this, the value of this meridian that passes through A to B, like this, A, and then there will be one more like this, B. So whatever the value of these meridians is, okay, I'll realize, okay, probably this A meridian I'm going to show is somewhere 030 east, and Bravo also I'll show as 030 west. It's hypothetical, close to real, nothing is like to scale right now. So now I know alpha, my departure point, is on a meridian 030 east, and Bravo, my destination, is on a meridian 030 west. Now you know how to do a D long. 30 degrees east plus 30 degrees west. You know 60 degrees. Which direction will you fly? You'll fly direction west, A to B. Remember, this is east, 90 degrees, and this is west. So if I maintain this Rhumbline straight line direction, I know if I maintain the same latitude, if I say that this latitude, okay, if I say that like this, these are different latitudes right now. And if I say that this angle is 10 degree north, and my 10 degree north parallel is actually connecting A and B like this. So this is 10 degree north parallel. So both my points A and B are actually on 10 degree north latitude. So now my alpha Bravo position is 10 degrees north, 030 west, and alpha departure is 10 degree north, 030 east. So this is how the whole graticule system helps you pinpoint. But what I've done is I've done it in a reverse way to show you how easy it is to pinpoint both those points. We had nothing, we had a blank paper, but now we have the whole earth as a globe right now. And we have all specific details. This is as good as your real stuff gets, okay, students? You have to learn this to get there. You need this information. You need it for your exams, and you need it for all your future flight planning purposes. Whatever we learn is 100% applicable in your field. Okay, it's not just for textbook, not just for clearing exams. It is the real deal that you're learning in class. So this is Rhumbline. But remember, students, this Rhumbline is not the shortest distance. It looks like a short distance here. It's an illusion because the Earth is a sphere, and what we are making is a 2D diagram. The better route, as I said earlier, is the great circle shorter arc between those 2 points. And the great circle shorter arc would actually look like this. From A, if I'm traveling westerly, because Bravo is in the west side, then in the northern hemisphere, if I'm going westerly, then this is what happens to my great circle track. This is natural, students. This is the path that you will have to take. Although on a 2D diagram, it looks like the great circle track that I have made. This is your GC track. And in bracket, you will write smaller arc of your great circle track. What is important here, students, is the direction. Okay. Here, if you're traveling from A to B, you are in the northern hemisphere and you're traveling westerly. Now, what happens whenever you are in the northern hemisphere traveling westerly? These are the questions that you'll have to answer. Okay, now you look at it. And remember your technique to remember directions, which is cardinal points. Make your cardinal points like this. Okay, north, east, south, west, a small square over there. And look at the first direction from A. This is the first direction from A, like this. You divide your great circle track in 3 directions. The second direction is this, and your third direction is this. You divide the great circle track in 3 directions, then find out the value of these directions. How do we find out the value of directions? Make cardinal points and make a line parallel to it from your cardinal points. So this is your first direction. What is the value of this direction? From north, clockwise, around 315 degrees. So your initial great circle track from A to B would be 315 degrees. Then you will turn left and you will fly this line. This line is parallel to west. So here my great circle track would become 270 degrees. And then after I have traveled 270 degrees, that is west, I'll take a left turn again. And this angle, I'll make this like this, parallel to it. And how much do I get? Clockwise, 225. I'll get 225 degrees. These 3 directions are my 3 great circle tracks: initial, midway, and final. And if I follow these 3 directions, then I'm meant to reach my destination following the shortest path on the great circle. While what happens for a Rhumbline, the Rhumbline gives you one common direction, 270, fly a straight line. Great. But because of the curvature of the earth, what looks like a straight line is actually a curved line on the earth's surface. So Rhumbline is actually a curved line with a constant direction. And great circle, which looks like a curved line on a 2D diagram, on earth it is actually a straighter line. That's why all your ATS routes look like straight lines to you. This is how we understand the directions of great circle track in the northern hemisphere when you are going westerly. The simple question asked to you would be, are the directions increasing or decreasing? What does it mean? Initially you were flying 315. So is your direction decreasing from 315 or increasing? Your second direction is 270. So 270 is lesser than 315. So your direction is decreasing. And then the final direction is 225, which is lesser than 270. So even that is decreasing. So what you're going to ask is, for a great circle track in the northern hemisphere, when you're flying westerly, your directions or your great circle track directions are decreasing. Now, what was I doing with the flight radar example that I was showing you? It was, we could understand it was northern hemisphere and we were going easterly, because I'm showing you all again. It's going to be a little difficult to track that plane directly. I think we found it. Yeah, see, it is going towards the right. That is easterly, simple as that. And it is in northern hemisphere right now. Earth is close to the equator, but in the India is close to the equator, but in the northern hemisphere. So the same example, what is happening is what I'm going to show you. In the northern hemisphere, when you're flying easterly towards your right side, it means you're choosing to fly from B to A now. You're choosing to fly B to A. You divide your directions in 3 from B to A. The initial great circle track from B to A, or your reciprocal track as we call it. Make a parallel line to it from your cardinal points. How many degrees? 45 degrees. So 0, 4, 5. Then the next track goes parallel 90 degrees, 0, 9, or 0. And the next track goes again like this, which is 1, 3, 5. 135. So when you are in the northern hemisphere and when you are going easterly, what happens? Your directions, do they increase, decrease, remain the same? For a great circle track, the directions are increasing from 045 to 090 to 135. And you have to make all your right turns. So northern hemisphere easterly, your directions are increasing. And if you look at this example, also initially, see, another aircraft is flying the same track right now. Indigo also is flying the same track. Till so far, here they are going to change and go left right now. And this was our aircraft. So initially, if I have to show you, okay, students ignore the ad. Now, if I have to show you with respect to this picture, how the great circles have changed, the great circle track, these are the cardinal points. Okay, right now the great circle track is this. Earlier, the great circle track was you can always find it out from anywhere. See this angle. Earlier, the angle looked very less, 004 degrees or something. And then it is changing to a higher value. From here, it looks like 20 degrees or so. We saw it was 19 degrees. It is in the northern hemisphere going easterly from 004 to 020. The direction is always increasing. This is a common fact. You don't need to think that this is some rocket science for you, but because you're starting it for the first time, some of you all are revising it today. So you have to make sure that you understand this logical concept. All big PICs, they use this plus symbol to determine the directions. This is something that they work out in their cockpit mathematically to determine where they are supposed to be. And this technique that I'm giving you all, this is really going to help you all if you stick to it, to determine your directions, your great circle tracks, and so on. Now, to say again or to repeat, what happens to my great circle directions whenever I'm flying in the northern hemisphere, westerly? All you need to figure out is whether your destination is east or west. That is your first priority, students. Only then you will get things right. This thing you can memorize. What I'm giving you, this table right now, you can memorize. But I want you all to logically remember the explanation of it. Don't just go to your ID, or whatever you come across in your navigation textbooks. If you remember this, you'll always come to the correct answer. Now let's quickly look at your southern hemisphere westerly and your southern hemisphere easterly. Now let's look at two new points. Let me tell you, okay, this is Charlie, and let's say this is Delta. In the southern hemisphere, if I'm going westerly, for me, the real sense of direction is what matters when it comes to east and west. So this is a Rhumbline again. Going westerly, always 270, you will get close to 270. Westerly could be anywhere between the range from 225 to 315. That becomes westerly properly. Anything above becomes northwesterly. It is all your understanding if you're going westwards or northwestwards or westwards or southwestwards, like that. But this Rhumbline is going to be a longer distance. So I need a shorter distance. So I need a great circle track. So my great circle track would go like this, students. What you see in the diagram is what your theory is completely based upon. Between any 2 points, the Rhumbline is always closer to the equator, or the Rhumbline track. If you choose to fly that track, it's a line of constant direction. It is close to the equator, while a great circle between any 2 points is always close to the poles, always. These are important facts that you're going to be given as notes and you have to remember. So this understanding of diagram, between any 2 points, the Rhumbline will always be closer to equator, be it southern hemisphere or northern hemisphere, compared to the great circle track. So now quickly tell me, students, what is happening when I'm flying westwards to my directions? This is my first direction. This is my second direction. This is my third direction. I make cardinal points. This is my first direction, 225. This is my second direction, 270. And this is my third direction, 315. Simple. So in southern hemisphere, when I'm flying westerly, my great circle directions are they increasing or they decreasing? They are increasing. And opposite to it, when I'm flying easterly in yellow, that is from Delta to Charlie, reciprocal track. Do not make it on the upper side, okay? Yes, students. So this is it. How do you figure out the first direction, second direction, third direction? First direction is this, probably 135. Second is 090 east and third is 045. Whoever is not thorough with this technique, you have to get in touch with me, write it in your parking lot. I'll make sure you're thorough. This is the easiest and the most important technique when it comes to imagining your directions. Your in-flight navigation, VOR, DME, radial sums all become easier. Great circle track also. So when I'm traveling easterly, southern hemisphere, my directions are decreasing. So this is how you will see your shortcuts given to you. DIID. This is what they give you in your textbooks. How is it? It means if you are traveling from here to here, your directions will increase. If you are traveling from here to here, your directions will decrease. If you're traveling from here to here, directions will increase. Here to here, directions will decrease. Why mug up when you can understand and then remember that point? Are we all following? Take a couple of minutes, everyone. See if you have any doubts. Yes, no, maybe. I need acknowledgement from you all. Nehal, how do you read? Nehal, try to put it in the chat box if you cannot reply verbally. Manan, I hope you're following. Shraddha, I hope you're following. Viral, try. Azam, try your best. Write everything in your parking lot. You're just doing something extra, which I appreciate. So, Bharat, for you also, whatever you're following or not following, let's check that. Feel free to ask.
I'm following you, sir.
Good, good. Why are we doing great circle track all of a sudden, students? We know the importance. The shorter arc will give us the shortest distance between the 2 points. Correct, Vivek? Memories? Nandini, memories, any doubts, anything that I have missed, we should add, please feel free to speak. Sujal, the same applies to you. I hope it's a good revision for you all. And students, anytime you feel that you have done it and you're thorough with it, you can do something else also, okay? Like, I don't mind you all. It's not compulsory for you to attend if anybody has gone through the session. But I like it when you're revising and learning and clarifying your doubts, because our exams can happen anytime now. So, yes.
So what if we consider a case like we move from southern hemisphere to northern hemisphere, like from the point Charlie to Bravo?
See, if you're traveling from Charlie to Bravo, there will be one great circle track and there will be one Rhumbline track like this. Okay. Mostly, if you are majorly in the southern hemisphere, then mostly your track, the great circle track that will be made would look like this, and your Rhumbline would look like this, straight like this. So this will be a great circle track. And because majority of it is in the southern hemisphere, the law would remain with respect to what we follow in the southern hemisphere. But this is what is going to happen to your direction. So if I make a cardinal point again, then I'll see my first direction is somewhere around 280. Then the second direction is somewhere around 315. And the third direction is somewhere around 325. So it still follows the opposite directions in that case. If I'm flying easterly in the southern hemisphere, westerly, right? So it has to be increasing, and it is westerly. It is northwesterly, so it will follow westerly only because your directions are increasing, although very slightly. But it will follow majority of which hemisphere it is in, and what is the majority of direction. Although I said it is northwesterly, will follow westerly. Remember, students, if you have to determine east-west, okay, anything coming in this direction is west, like this. This is west, this is west, this is west, this is west. Even this is west for you, and this is west for you, like this. All this can be considered west, but ideally, any part between this point would be northwest. And then this point again could be said northwest or west. Similarly, this much point is mainly called as southwest, like that. This is also west. There's a very thin line. You determine what is the best understanding that you have. But coming back to the query, majority, it is following the southern hemisphere going westerly track only. Southern hemisphere westerly, directions increasing, because my direction of flight is towards the west. And how did I figure out? Simple. Anything on the left is west, anything on the right is east. Who was asking this doubt? Please use your call sign. Is it clear?
Yes, sir. Affirm, sir.
Azam, correct? Azam, yeah. Good. All this is east. Remember, students, I'll reiterate something that I said. The keywords are 60, 360. These are two key numbers that regulate everything. When it comes to 360, it's all your directions. And when it comes to 60, it's the understanding 60 degree, 1 degree, 60 minutes, 1 hour, 60 minutes. Then the 1/60 rule that we follow in in-flight navigation, like that. Okay. These are your strong points. These points, if you master, students will be a natural in clearing your navigation exams, because every topic has certain fundamentals. And this topic, fundamentals are nothing but your cardinal points and your understanding of great circles. And although Rhumbline I have just discussed with two terms, that much is enough to give importance to Rhumbline. Another point I have already discussed, that on the Earth's surface, the Rhumbline is a regularly curved line. How do we get the same distance, same direction for a Rhumbline? How do we get the same direction for a Rhumbline? We say that the Rhumbline cuts all meridians at the same angles. Like if it is cutting the prime meridian, it is the same angle like this. If it is cutting, say, this meridian, it is the same angle. It is the same angle. Like I'll show you all again. Now I'm going to show you a reference view only about the upper or one hemisphere. Okay, right now. So this is your equator. If the whole line is equator, and if I say this is your prime meridian over here, only the northern hemisphere if I have to make, okay, prime meridian, just making the northern hemisphere. Then I know that up to one point I will have 0980 west, and up to one point from my front view I will have 0980 east, this meridian. This is only the northern hemisphere of the earth. Now what I'm trying to show you all is that your meridians are placed like this. Okay. Now, if I say from 00 degrees east-west to 020 degrees east, if I make this d long over here, I get what? 20 degrees into 60, because 1 degree is 60 nautical miles on a great circle, and equator is a great circle. So I can easily calculate the d long between A to B. 20 into 60 nautical miles is equal to 1200 nautical miles on equator, because it's a great circle. But the same if I have to find out on 30 degree north and the parallel of 30 degree north, this whole line. So now if I say that my position departure destination is prime meridian and 020 east, but latitude is not equator, latitude is 30 degree north, like this. So what happens if I compare on a great circle? My distance is approximately on the scale also, if I have to check, 1, 2, and 3 centimeters on this digital scale that I'm using. And on 30 degree north, it is almost 2.2 centimeters. Although the d long is same between the two. D long is 20 degrees east, 20 degrees east, but the physical distance on higher latitudes is smaller compared to the physical distance on a lower latitude or an equator. This is because your meridians are converging towards the poles. And this angle of convergency that the meridians have towards each other, if you can find out the convergency angle between the two, you can actually figure out the actual distance between your departure point and your arrival point. That is your mean d-lat or mean latitude that we say. Let's say that you have a place at 20 degree north. Let's say this is your parallel, and let's say it's on prime meridian, and this is position Charlie. And if I say you have to go from Charlie to Bravo, then you will take this line, straight line, but still you will need to know how much is the distance, because my great circle is going to be somewhere like this. If I have to make my great circle in Rhumbline, on this chart would look like this. The line in green is your Rhumbline, and the line in red is your great circle line, because you're in the northern hemisphere going easterly. Okay, so this is something that we learn through a concept known as convergency, which is the inclination of meridians towards each other as they are merging towards the poles. And this angle is actually found out by making a normal like this, a straight line like this. Something goes like a straight line to your curved line like this, and the angle of inclination is found between the two meridians. It's known as convergency angle. And this is what is convergency called. This is what is convergency, when your meridians are converging towards each other. On the equator, there is zero convergency. On the equator, they are not inclined towards each other. On the equator, the straight line will be a straight line like this and like this. But as you see, as you go to your higher latitudes, the meridians will always start inclining towards each other. Even if you're talking about prime meridian, it will be straight, but other meridians would be converging towards that particular meridian. And that is something that we calculate, convergency and convergency angle, and we convert that into our rhumbline and great circles to find the other. Sometimes you'll have to find rhumbline track, sometimes you'll have to find great circle track, or sometimes you'll have to find convergency angle. And that is what is the most important element of your Earth as a general navigation chapter, to be able to make that final calculation between rhumbline, great circle track. Okay. Interestingly, if you go through your navigation computer CX3 or the emulator that I've shared, in that, if you put latitude and longitudes, you can determine one track. Now, is it JC track or is it rhumbline track? That is for you to do some R&D before tomorrow's session. Okay. If it is rhumbline track, and if you can find out rhumbline track using your navigation computer, then all you need to do is find out convergency between A and points, which can be done with your formula. And using convergency and rhumbline track, you can do a mathematical solution to find out your great circle track. Okay. Vivek, Nandini, and Sujal. So you have not done it on the navigation calci, so it is something new for you to try. So do play around with your navigation computer and put any random hypothetical A and B coordinates and see what do you get. Do you get a rhumbline track or do you get a great circle track? Okay. And whatever you get, students, using that will be finding the other one. So your job becomes much more easier. Although you don't need your navigation computer to find all this, but that is a lengthy process now, which we really don't need to get into because we are allowed to use navigation computers also. So that is convergency. That is great circle track, great circle directions. Rhumbline also, we know what it is, a regularly curved line following a constant direction on the surface of the Earth. How does it get it? By cutting all meridians at the same angle. So if I have to show you that, then see this line, it is maintaining a 23-degree angle right now with all meridians. So if I take this line like this, it becomes my rhumbline because it is cutting all meridians at the same angle. That is what a rhumbline is. On a 2D chart, rhumbline looks smaller and straight, while great circle looks regularly curved and long. But on real Earth, the great circle is much more straighter and the rhumbline is much more curved. Great circle is much more smaller and rhumbline is lengthier. And how did we come across rhumbline? So in olden days, when aviation was not there, when aircrafts were not used at all, not invented also, people used to travel using ships, maritime navigation. And what used to help them travel safely used to be the rhumbline tracks only. So they used to follow rhumbline tracks. And if anybody has seen any pirate movie or sea movie, you must have, maybe now if you see, you'll notice that they will always emphasize on maintaining a constant heading, and probably they will change 2 or 3 headings to avoid obstacles. It is like that. Your directional references from 0 to 360 degrees are your lifelines when it comes to navigation. And navigation, it is not a child's play, but it is an art and a skill that you can acquire. Even a child can acquire because it is very limited in content. Okay. And if you learn the basics and your fundamentals are strong, you will become a good navigator. By the end of your training session, I am sure you will clear your papers. But are you a good navigator or not? You should understand, so far, sir, I have not flown, but I think on paper I am a good navigator, because these things will really help you when you're doing your instrument rating and multi-engine. Before that, you will not realize much because everything is very easy. But after that, your theory will knock on your mind saying, oh, had I learned this, had I learned that, how can I make sure that, I'm doing the perfect turns, perfect arcs, will I pass my test or not, and so on. Your departure is your rhumbline distance only. So either east-west or north-south. So departure is just a different formula that I'll give you, but it is similar to your rhumbline track distance. So that is departure, great circle, rhumbline, and convergency. Introduced to you some of the points we have discussed in depth. Tomorrow is going to be a final session where we are going to have an amalgamation of all these points and do certain numericals. So remember, tomorrow we should be stretching till 7:30 or probably 8. I'll give you a good 15-minute breather in between. We'll have fun and we'll study together both. Fun in the way, we'll just do some interactions and solve a few sums and see how many students are getting it right, not getting it right. I'll help you solve. So see if you can get your scientific calci, because we'll have scientific formulas coming in. If you don't have it, it's okay. Use your laptop, computer, mobile phone, anything scientific calci. And CX3 emulator I have shared with you all. If anybody does not have a CX3 and wants to practice, let me know on WhatsApp. I'll share the link with you all. Okay, students, now you have some minutes. Please go ahead if you have any doubts, or else we are good to go with our class for today. Vivek, your answer is correct. I want you to try and do certain calculations. Try to go through your notes, revise, test yourself how much you remember. See if you can find great circle track by giving any two coordinates, have convergency angle, get the Rhumbline from CX3. Yeah, Vivek.
I had tried one
Is it working?
exam.
Working? Are you able to solve?
Yes, sir.
Good, good. Students, what is a track? It's a line of direction. Cardinal points will always be cardinal points. Okay. So what is a track? It's a line of direction that you follow. A track is something that you have to follow, a line or a direction you have to follow to reach your destination. What is a flight path? Flight path is the path traced by the CG of the aircraft. What is heading? Heading is the direction in which the aircraft nose or longitudinal axis points. In zero wind conditions, your heading, your flight path, and your track are all the same. But if you get wind which keeps happening, then your heading would be a little different. Your track has to be maintained. And if your flight path and your track is maintained, then you're good. But if your flight path and track are different, then what you are on is your track made good, and what you have to be on is your required track. So I'm only talking about students who have been studying since a long time, not the freshers. I hope discussing these points, the bells of those topics are ringing in your head right now. Everything is connected, right? And students who have not yet been introduced, do not worry, your time will come for that. So anybody wants to share anything? Sorry, I just started teaching, didn't take introductions, didn't ask about your well-being. Though I'm in constant touch with you also, I'm aware. But if you have now this calci will work SVPAM FX 82MS. It's the model. It comes from around 350 to 450 bucks online. It could be less, it could be more. You have to make sure that it is not programmable. Don't get the fancy ones with LCD displays and all. It should not be programmable. That's it. Okay. Yeah. Varad, go ahead. You're on mute, Varad. Yeah, unmute. No, cannot hear you. Check your mic. No, radio 1. Varad, type in the chat box. Others, say something. Vivek, say something. Somebody do a readability check.
Radio 5, sir. Victor Tango, Victor, Victor Alpha.
Yeah, fine. Varad, try again. Your microphone is disconnected. No, cannot hear you. Type it in the chat box, Varad. Okay, Viral, I have written it down. It's called S. This is its code. But this is the model number, actual model number. Older one is also allowed. This is also allowed. Okay, both are allowed. Anything that you don't have to program is allowed. Okay, students, remember this much. Convergency is maximum at poles and minimum at the equator. Yeah, Varat, because equator, there is no convergency. The inclination between any two meridians is 0, and it increases as you go towards the poles. So it's a logical thing, and what you're saying is true. It is something that we all are going to discuss in the next session. All important points. Okay, Varat? Right. You're right. Great. So students, I'll take your leave. Enjoy the extra time, be in the flow of studies. For examination students, we are going to resume your afternoon batch also simultaneously. So we are going to now be on our full pedal to the metal. Yes. Pedal to the metal, yeah. Like full thrust. And we are going to not stop till the time your exams are. Other students, take it easy, study as much as you can. I'm going to start a fresh batch of regs and maths also. Most probably this week we'll have our first sessions. So existing students who have not yet started other subjects, there will be something different for you all, but the timings would be same for you. You don't have to give extra timing. So we'll have the evening slots only. And alternate days we'll have evening navigation, and we'll be resuming evening RT sessions also. And for all examination students, you will have extra navigation regularly in the afternoon, along with the alternate evening navigation sessions. Okay, so you will get good time to practice. And this week onwards, you're going to get practice material also. So let's have a very dedicated attitude towards it, whoever is going to appear for the exams. And others, just relax, enjoy, study. And if you have any other requests, let me know. Okay, I'm taking your leave. Alpha 22 RTR batch, 7 o'clock students, whoever is joining. Others, you will be shared for the next tomorrow's schedule at night, I guess, but you have a soft update. Tomorrow, 5 o'clock, we have navigation. Take care, students. Do revise, and whatever doubts you have, let me know. I'm taking your leave now.
Thank you, sir.
Bye, everyone. Take
Thank
care.
you, sir.
Thank 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 you, sir.